Good morning, judges. Thank you very much for your time and allowing us the opportunity to present the Rosh Pinah project, which we've executed. I'd like to first just start off by just going around the room and just introducing everybody. John, would you like to introduce yourself and Hannes, if you wouldn't mind, please, and then I'll come back.
Thanks, Colin. Hi, judges. My name is John Mitchell, and we assisted in the execution of this project. And then I'm going to hand over to Hannes Dursewey, who was the guy on the ground and on site doing the physical execution.
Hi, judges. I'm Hannes Dursewey. We executed this Rosh Pinah expansion project 2.0 as I was the site manager.
Thank you very much. I'm Colin Gibbs from Viva Engineering. So I think as a starting point, I'd just like to, I think one of the big things we'd like to try and get across on this presentation is the partnership between Viva Engineering and NUMI in Namibia. So there's a partnership that's been in place for the last 5 years, and it's primarily been forged out of the need to create a single entity that can provide first world manufacturing and then first world installation on site. So we're going to take you through this presentation and just show you how in this project we managed to achieve that. And a lot of companies feel that they need to split the scopes to de-risk projects, and what we've proved is exactly the opposite. With our partnership, the NUMI Viva partnership, we're able to offer clients turnkey supply and install solutions for large projects in Namibia. All right. Thanks, Hannes. Do you want to kick off there, and we'll just chip in as we go, if that's okay.
So, okay, so the project we wanted to nominate is for the RP 2.0 Phase 1 project, situated in Namibia, Rosh Pinah, down in the south. Mainly we had 3 or 8 different areas of execution. The project full completion date was start date was 2025, 11th month, the first. The project value was 134,366,559 million. It was a structure steel buildings that we executed. The main project consisted out of 8 main components. It was the paste plant, water treatment plant, the thickener installation with an access tower, pipe rack, SPS tanks, compressor areas, 2 cement silos, and 2 backfill paste feed tanks made from steel plates. I think one of the main key challenges we had on this project was due to the fact that it was a cross-border project, and we are plus minus from the nearest border. We are almost 2,000 kilometers of getting the material onto site. Steel was fabricated in South Africa at Viva Engineering, transported down. I think we had almost 195 truck deliveries full of steel, plate work and pipes. Colin, do you want to add something here?
No, I think that's exactly right. I think this project does form part of a larger project that we've been involved on site. So today we're presenting the phases 1 and 2, and phase 3, which Choppy alluded to now, included a total of 190 odd trucks to site over the period. So from a steelwork perspective, as you can see, the value of the steelwork was around 20 million rand. Round figures, the tonnages was just over 650 tons, and it's a real mixture of hot roll sections, cold roll sections, used for various applications, which we're going to take you through now. I think on the cladding, could you maybe chip in there, Choppy or Hannes? John?
So yeah, from the cladding side, you guys can see that it was IBR cladding that used, type of chromodeck, coated on the one side, roughly about 2,500 square meters, and round figures about 2 million rand of cladding that we installed on the paste building.
Okay, as I mentioned, the structural steel engineers on site and the execution engineers was DRA Global Limited. Steelwork contractors, steel was fabricated by Viva Engineering, and then the installation was done by K. Neumeier. If I just can quickly take you guys through, so one of the main features of the project was definitely the 2 cement silos. The cement silos came in as segments, and we erected, pre-assembled and welded them on site. As you can see, the first slide here is where we did the pre-assembly and the pre-welding, and then from there we moved to site where it was lifted into place. And I think you were talking about around about 28 meters in the air, we did a complete weld on it to keep it in place. If I go through to the images, this is the paste area where the 2 silos were also installed, with the paste fill, backfill standing here. It's standing roughly 38 meters in the air. We have here the pipe racks running here for the piping running from the backfill to the brownfields area. Most of the work here was done in a green field and connecting into a brownfields. We have the access tower of the thickener with the thickener and the bridge that was installed.
Sorry, Hannes, maybe stop there and just maybe allude back to the challenges that we had with the cement silos. So due to the fact, if you just maybe go back one slide, the judges will see that it is very confined space there, because there was also a lot of activities for the current operations, and then particular planning had to be given for the installation and the rigging. So we had to use two cranes in order to rig it in, because we had to basically lift it from a horizontal position and then lift it vertical, and again that, and the 250-ton crane was used to get that huge silo into position. So particular emphasis was given on the planning and also to make sure that operations was not hampered. So that was quite a detailed plan that the site guys had to do.
I think there's to chip in there as well. Again, as John mentioned, so this entire project was executed on an existing mine, and at no stage was any of the site, the project or the mine operations affected by all that planning and all the work that had to get done. So as John said, a lot of planning and integration with the existing mine operations had to be done to ensure that there was no influence or no stoppages on the operations of the mine. Thanks, George.
Thank you, guys. As you can see here, this is also part of the pipe racks running here. So we had roughly 9.5 kilometers of greenfields piping to install brownfields piping in the existing running plant. We're talking about also 6.5 kilometers of piping that need to be installed. As you can see here, this is the top level of the backfill paste plant. We at this stage already installed the filter. We'll get now to the filter story, quite a interesting one. And then we have the scaffolding already installed for the cladding and for the last installation of the roof structure. I think one of the big positives from Viva Engineering and from Neumayer is the Tekla BIM model that Viva Engineering implemented with this project. It's a 3D modular service that designs the steelwork for us, the items we need to install. Through that, we can just enter, see which beam comes where, and that makes it easier to look in the laydown what is needed for the installation. They also use the barcode system, tracking from the manufacturing straight through to paint tool site. We can use a barcode system and clearly see what is installed or in what state is the item.
Thanks, Hannes. I think if I can maybe just chip in there. So as Hannes explained, so all the shop detailing was completed by Viva Engineering in Tekla. And as Hannes mentioned, the BIM model was a key component to the success of the project. Firstly, from a approval process with the client to make sure that obviously the detailing was done in accordance with the structural design of DRA. And that whole approval process, making sure that there was optimized, at least optimal approval processes. And then, as Hannes said, it became a key function or facilitator for site to be able to easily erect the steelwork on site. Hannes just touched on our portal. So Viva's got a information portal that we've developed over a number of years, which again is key to the success of our partnership with Neumayer. So the portal is developed to be able to track everything from detailing right through the fabrication process transport, and then also the site components, giving the client a complete singular view, as much as there might be two companies in partnership here to execute the project, giving the client a complete single view of the progress. The portal updates every 3 hours, so the client can see at any stage progress throughout the entire process, from detailing through to site erection, of everything being as old as 3 hours, which again became, we believe, technologically one of the biggest differentiators that we've got on this project. Thanks, Hannes.
Thanks, Colin. So as we just run through the slides, this is the different areas, as we explained, the different key 8 key areas. We just talked about the Tekla, so this is an example of the Tekla snapshot we just took of the paste plant, showing the different steel components, and as I mentioned, you can just click on it and it can tell you exactly which component is it and where it needs to be installed. Here's the full paste plant that was built. 100%. You go over to the cladding. Cladding was manufactured by Country Roofing, rolled also by Country Roofing in Namibia, and then the installation work was done by K. Neumeyer. As John said, we're talking plus minus 2,500 square meters of cladding was installed. We use a normal chromadeck cladding from a 1.6 to a 1.8. It was coated by Duff Grey. Then all the major buildings we installed the cladding. Fabrication was done by Viva Engineering in South Africa. Colin, you're going to take this one for us.
Yeah, so I think probably the most sort of complex portion that we're kind of touching on here is the water tanks that had to be detailed with two things in mind. Obviously the engineering requirements, but also the transport requirements, and then also how it was going to be physically built on site. So in the pictures you can see here on the right hand side, you can see numerous sections of the steel water tanks that were fabricated, rubber lined and painted by ourselves in Johannesburg. Obviously nesting done to ensure truck optimization, as you can see on the left hand side over there, and then obviously transported to site in a sequence that made site erection as easy as possible. A constructability study was done with our partners to ensure that we were providing the items in a safe and constructible way for that optimized site. Again, just some more pictures there of the cement silo. Again, just basic ITPs that were in place to ensure that all parties inspected and were part of the inspection process throughout. Can carry on there. Thanks, Hannes.
Yeah, over to the erection and installation. So as said, Kenona did the installation. I think one of the main challenges we had, as I mentioned, is that most of the work that was carried out was done in a live plant, and the congested areas was quite challenging for us. And as Colin said, also we had to work all the time together to make sure that the plans and the installation and the arrival of the different components and steel work, plate work as well, took place on the same time to do the installation. A lot of the work was working at heights, as in there, plus minus 20 to 35 meters. And then again, the logistics, the access of the items coming to site. Traveling over a border was definitely a challenge for us, getting all the permits and the abnormal loads, getting them on site. How we managed it, as mentioned, is we worked quite in a manner that each week, plus minus, we had 2 construction meetings, seeing on which stage we're standing and how we can fast track the items, getting them on site and doing the installation. One of the pictures down here, as you can see, was the installation of the thickness bridge. We used a 110-ton crane to do the installation. Normally, these types of bridge can be installed by a 55-ton crane, but due to the area that is so congested, we went with a higher crane just to get in the steelwork. Yeah, as you can see, as John mentioned, while we were installing the cement silos, we used 2 cranes to do the top and tail, and then using the 250-ton crane to do the installation. Here it was just a 110-ton crane doing the bottom section of the silo, and that one was a 55-ton crane doing the installation or the top and tail for the cover. Right, some photos of the thickener area before the installation of the thickener, and here we were busy already with the installation of the access tower. Down here was the bringing in delivery of the cement silo, and then this side is the installation of the paste plant while they were busy, the civil teams completing the work for the SPS tank to be installed. Challenges and solutions. I think John can assist us here.
Yes, I think, yeah. So I think we've a lot of challenges was encountered, as Colin alluded earlier, was definitely the dovetailing and the integration from a detailing perspective to fabrication, and that Viva Portal was assisted a lot by using the whole system. And what also enabled us, we built into the system additional steps to actually give the client full visibility to see how many tons have arrived to site, the full traceability, and what has been erected or installed in the previous week. So full traceability was also done from that. So on, just the next slide, please. And I think the other thing, the challenge that we had was the confinement, and then also a lot of free issue equipment in the sense of mechanical item supplied by the client was also supplied to us, which we had to install. And I think the biggest challenge we anticipated, I don't know if you got a picture, Hannes, was the filter that was supplied free issue by the client. So was sent originally from Germany, or fabricated in Germany, sent via ship to Durban, and then transported all the way from Durban to Namibia. Just for the last turn into the mine, one of the straps on the truck broke, and the filter actually fell off the truck. So, I mean, all this due diligence has been given to that, and then we discovered, we stripped the filter system, and it has been tremendously damaged. So all the things, we tried to fix it on site, but it had to be sent back to Johannesburg. So I think that is one of the project's most big challenges. That's it. You can't leave anything unplanned. You have to check everything. So I think that was our biggest challenge from that. And that delayed the project slightly with, I think, 6 weeks in total, which we had to work around, make other plans, make sure that we uninstall certain sections of steel for us to install it later. Also made use of a bigger crane to come around that challenge in order to deliver still on time.
Thank you, John. With the benefits of steel in this application, Colin, are you going to take us through this one?
I think, again, from an engineering perspective, I think there isn't another product that can actually perform and as versatile as structural steelwork, specifically in a mining environment like this. Again, I think we saw some really, really big spans, some very complex connections in various areas of the project, a lot of modularization to ensure that items can be built on the ground and then lifted into position. Again, all talks to the sort of versatility of steelwork, and quite frankly, it's the only material that is actually capable of this kind of environment. Thanks, Hannes. Drop on.
100%. So regarding the quality, we are Viva Engineering use the 9001 certification to do all the steel work, and welding was the ASME they used. Third-party inspections was done in South Africa before steel was released coming down to Namibia for the installation. Colin, would you like to touch some base on your quality systems?
Oh, absolutely. Thank you. Again, quality assurance is always a big topic on projects, especially large international project like this. Again, as Hannes touched on it, again, we did all of the welding to AWS D1.1. Our inspections regime on the project ensure everyone was comfortable that by the time something got to site, there was nothing left to chance, as John said. Paint specifications and rubber lining throughout the project obviously were all done to the requirements of the project. Hannes, next one, please.
Thank you.
Okay,
so
Thank you.
Okay, so I just would like to take you through some of the pictures again. So this is one of the SPS tanks that was installed. This is a jacking system that we used to install the tank jacking, installing the roof section first from the bottom up. The sides were installed and jacked up. A top view here of the paste fill plant, the silos, the 250-ton crane still in place, the compressor area, SPS tank, and then the water treatment. What we were proud of, I think one of the main thing is safety first. I think we had a really good run of safety here, installation and through the fabrication. We did, if I'm not mistaken, 1.5 million hours LT3 for the project to be completed. Proud of the footprint being one of a kind. I mean, with our turnkey solution, the support we give our clients is something we can be proud of, and that's why they normally come back to us. Colin?
Yeah, I think from our side, I think the thing that I'm most proud of is the teamwork and the way that, again, two companies can work together so intertwined and so seamlessly. It was actually part of the recommendation or from the client, where they basically said it was a seamless operation between the two companies, and I think that's what we offer our clients, is the seamless teamwork, the way that the team, as Hannes mentioned, met weekly to ensure that we stayed on track, the items were arriving on the site and being installed. So it's that teamwork and that sort of solution mindset that we provide our clients, which I think I'm exceptionally proud of on the project. Thank you.
John, would you like to touch base something?
No, thanks. Honest, I think you guys have covered everything from our side. Thanks.
Okay, 100%. And yeah, thank you. That's from my side. Colin?
To the judges for your time. We really appreciate your attention and your thoughts, and we'd love to invite you to our site, if you can make it to Namibia, to come and visit and see firsthand what we've achieved. John?
Yes, thank you, Colin. I think that is an open invitation to the judges. If you can make it to Namibia, we will show you gladly around. So thank you, judges, for your time.